Okay, so I got a beam. It's got 3 boards nailed together and shown. I know it has a moment of 600 Newton meters acting at it. I want to find the maximum bending stress in this guy here. So that bending stress equation, my flexure formula is mc over I. Okay, where m is the moment, that's 600. C is the distance from the neutral axis, and I is the moment of inertia about this. So if I look at my area right here, right, I'm going to have a neutral axis that is offset just a little bit, okay, like so. Okay, and I need to find that first. So I need to find the centroid of this area right here. And as you remember from statics, the centroid is found by breaking it up into pieces, where you take the centroid times the area of one piece, add those together, and divide it by the total area of this. Okay? And the way that I am going to do this is I'm going to take two rectangles. Okay? Kind of a bigger outer rectangle and then a smaller inner rectangle that I'm going to cut out. Okay, so for that outer rectangle, the centroid of that is going to be half of 175 because it's 150 plus 225. So that's going to be 0.0875. Again, I'm going to do everything in meters. Okay, and that's going to be 240 or 0.24 times 0.175. Okay, that's going to be the outer. Okay, and then the smaller rectangle on the inside, okay, will be minus. It's going to be at 75, the centroid of it, so 0.075, and then that's going to be 200 by 150, so 0.2 times 0.15. Then I divide that by the total area, which is the outer minus the inner, so that's going to be the 0.24 times 0.175 minus the 0.2 times the, bear with me a second, 0.15. Okay, and from that I find that the centroid of this guy is at 118 millimeters, or 0.11875 meters. So that's the center, that's where the neutral axis is located from the bottom. Okay, that's also what C is going to be, because I've got that distance. Okay, I've got this distance, which I've got C. I've also got this distance, right? Because the maximum stress occurs at the edge, right? Well, to find the ultimate maximum one, I want to use whichever one's busy, which is bigger, which is going to be the 118 as opposed to the whatever it is, 65 or whatever it is for going to the top. Okay, so that is going to be the C that I'm going to use. The other thing I need to find is the area moment of inertia, which of course we remember from statics as well, using the parallel axis theorem. Okay, so again, I'm going to use the bigger one and the smaller one. So the bigger one, okay, is going to be 1/12 times 0.24 times 0.175. That's the area moment of inertia of a rectangle, 1/12 bh cubed. Okay, now I do the parallel axis theorem, which is the area, which is 0.24 times 0.175, and then now this is the distance from the center of the whole circle, or I'm sorry, the whole rectangle, minus the axis I'm trying to take it about, which is the centroid, which is going to be 0.11875 minus 0.0875, which is again where the center of the big circle is. Okay, so from that I'm going to then subtract off the other one, which is going the smaller one, which is going to be 1/12 times 0.2 times 0.15 cubed, okay, plus 0.2 times 0.15 times, now again, it's that distance between the center of the smaller one and the neutral axis that I'm looking for. So that's going to be 0.11875 minus 0.075, and then that's going to be squared. So the moment of inertia about the neutral axis then, when I calculate this out, is 34.5 times 10 to the minus 6, and that's going to be meters to the fourth. Okay, so hopefully you remember how to find the centroid of an area as well as the area moment of inertia. If not, you'll want to revisit that in your statics course. But now that I have this stuff, I can go ahead and calculate the maximum bending stress, which is going to be that moment, which is 600 Newton meters, times C, which is the furthest distance I can get from the neutral axis vertically, which again is 11875, divided by the area moment of inertia, which is 34.5 times 10 to the minus 6. And from that, I get 2.06 megapascals as my answer. Okay. So again, flexure formula is pretty simple. You just have to remember how to find the centroid, how to find the area moment of inertia, but then it's just kind of plug and chug at that point.